Hi everybody. I thought I would give you a little lecture on tables and swing. This is all based out of chapter 18 of the Java for Programmers book. You can get the code on that if you buy the book. This is using the model view controller architecture. The model will contain the data for the components that go in the table. The view will be the table itself, and the table can also be used as a controller. And so when we think about the model, the view, and the controller, we see interactions in both directions. And so a big question is, why do we use a model view controller? And the answer is we separate our concern away of the data from the actual view and controller. It hides some complexity. But this is really very close to an observer-observable relationship. And so when we think about the model, we think about a place to store our data without presentation elements. When we think about the view, we don't feel like there should be any data there, just the presentation elements. And the controller acts like a mediator, which is the glue that ties the model and the view together. So the mediator design pattern is where you would do connections between the model and the view and the controller. Mediator is kind of like the wiring hub. So then the question is, what do you need a table for? And the JTable component is useful for presenting tabular data like a spreadsheet. And it has properties that include columns, rows, and cells which locate the data. And the way we deal with it is we import the JAVAX Swing JTable component. Then we can display the data in the table, and we can proceed to edit the table. And here are the constructors. And with the constructors, you can see if you just want to display the data, you can throw in some row data and some column data, and you can update these things at will. You can also put these things into a vector, just a series of rows, or you could use the table model. And when you're dealing with the model view controller, table model is the preferred way to go. And you can have a table column model, and you can have a list selection model, as well as a table model. So then you can separate out the table from the column, and then you can select large numbers of things. So here's a two-dimensional array consisting of a series of different reference data types, and what you can see here, and this is sort of important, 5 is not a reference data type. It's a primitive data type, but it has to be a reference data type if you're going to put it into the table. Therefore, wrapper it with the integer wrapper class. And once you do something like that with booleans and integers and whatever else you want to put in there, it'll be fine for creating data for your table. And for your columns, typically you throw in something on the order of a bunch of strings. That's for your columns, and you can see how they get set in here. And so there are several interfaces that you can deal with. One is the table column model, which manages the columns. That'll let you do a selection. It'll let you change spacing. And then the table model will provide the data. So table column events are caused by column model changes. Table model events are caused by table model changes. So you have to intercept and listen to these things when the model changes. So here's a table, has a column model, and you can get any specific column you like. And if it's a number that you're looking for, you can set the preferred width on that column. Otherwise, you can change the width to something else. So here we are changing the width of each column. And if you wanted to get different columns, you can make the second column larger than the others. And that's kind of an interesting idea. Right? I mean, go in through and resize all the table columns at will. Here's a thing called the abstract table model, and that requires that you be implementing the column count, the row count, the value at any specific location, and the column class. and how you would get the column at that location. And so if you want to make it so that you can have the table larger than can be seen, you put it in a J scroll pane, and that's a decorator for the JTable, and it adds sideways and up and down elevators. And so then that deals with the spacing for headers, and it does the right thing. And so for our example, what I've prepared is a small display table. And here we can see we've created a border layout panel. Got the content pane from the locally hosted frame, set the layout for the frame, and added the border layout panel to the frame. Then took the table, grabbed some data values and column names, and then proceeded to create a viewport, which should be filled. We set our preferred scrollable viewport size and the grid color, and we want to show the grid. Grids in a spreadsheet are just what you might think. They set up a horizontal line and a vertical line for each cell, and making them black gives you a color choice for your grid. And now what you do with your table is you use it as an argument to the J scroll pane. That's the decorator design pattern. Put it into your JTable, your panel rather, and then pack it so it's resized, and then set visible to true, and you should be able to see it. And there it is. Now these columns can be resized. You can see the borders are there. And what you want to do is you want to see the usage of the system. And so here we are. We grabbed some columns. We threw in some data, two-dimensional data, and then we just called display table, and we were there. Now let's try it again, this time with a little bit more data. And what we'll do is we'll go and we'll get some columns from a thing called the 2P table, and then we'll get the actual data in the 2P table and just display it. We won't be able to edit it, but we can display it. And there we go. So this is a resizable column. And that lets us have a little flexibility on display of our data. So just calling display table enables us to display the table. It doesn't do very much in terms of editing the table, but it allows us, in effect, to get a nice tabular display. Here's another example. This one is going to try and import some text. So let's see if we can find some text for it. And now we can see it's giving us an address book with some information and a phone number, and it's able to go through and display perhaps the first few elements in the address book. You can scroll around using the J scroll pane, which is kind of convenient. Let's try another example. In this one, what we'll do is we'll try a simple 2D table. Let's see how that works out. There it is. And now that has a thread that's changing the value in one of the cells. So to see how that works, as we want dynamically updated data inside of a table, you can see that what happens is you add a table model listener, and now we can print out table changed every time we change the table. Now here we're going to run this thread, and the thread is going to set the value at a specific location in the table model, and whenever you do that, it automatically updates the display. And then it sleeps, so what we'll do is let's get rid of the n equals and run it again. Now as it updates, you can see table is changing, and the table change keeps getting printed because of the inversion of control. We got to call back into the table model listener, and that's going to essentially allow us to figure out that something is changing in the table. And in effect, what's changing is this thread is going in and starting to muck about with the value at a specific location. And in fact, if you think about it, you could probably change all the values at each location. But you'd put in a doubly nested for loop for something like that. Here's another example. We'll try and do this with some stock data. So now we have a static stock data portfolio giving us the symbol name, name of the company, the last price, the open, the change, the percentage change, and the volume. And you can resize these things. You should be able to scroll around a little bit. And if you want to see how that data is put in, and that's static data, you should be able to see the stock data right in through here. It just comes in as something called a stock data element, which gives us the last and the open and that sort of thing. So when we go into the stock frame, and you want to see where it's pulling in your stock table model, what it's doing is it's making new instances of stock data, giving it all the elements that it needs, and putting it into a vector. And now what we're doing here is we're subclassing the abstract model, implementing the table listener, and in order to subclass the abstract table model, we have to provide implementations for get column name, find the column, get the column class, figure out if the cell is editable. In other words, we've got to be able to provide implementations for all of those methods. And so here we can see where we set the default data, get the row count, get the column count. All of this stuff comes from the superclass. And effectively, because we have column data stored in the data structure here, and there it is, we're able to proceed and get values at each row. So here we have row and column. We can go in and get the row for any element, and once we do that, we've got the stock data, and we can then proceed to return the value. So when somebody asks for the column number 0, we just do row.symbol because that's going to be in the 0th column. And then we do row.name for the first column, etc. So this case statement is making reference directly to the column number. And so that's how we access the column number when we proceed through. The table changed is in there because we implemented the table model listener. And table model listener requires that we handle table changed, and all we do here is print out that the table has changed. Although we could do something else, I suppose. And the data, as you can see, is completely static. This is not current data. Here is another example of using a table. I would call this the advanced example, and I'll just show you how this works. And what you've got here is a little spreadsheet. So you can say something like equals 9 times 9, and then that can be equal to, let's see now, f 3 times 10, and you can essentially use this as a little spreadsheet all built into Java where you get to resize each column individually. So that's kind of fun. Have your own little embedded spreadsheet. So that's what I have for you for today for JTables and my little JTable demo. Hope you like it. Thank you. Bye-bye.